Hello and welcome to my lesson on antidifferentiation and integration. First thing to consider is what is the antiderivative of 2x? Well, that would be x squared because the derivative of x squared is 2x. What about the antiderivative of 3x squared? That would be x cubed because the derivative of x cubed is 3x squared. What is the antiderivative of x squared? It's a bit challenging, and the answer to that is 1/3 x cubed. And you can check that by finding the derivative of 1/3 x cubed, and you will find that you will get x squared. Now, the problem is that with the antiderivative, there are infinitely many functions whose whose derivative is x squared. 1/3 x cubed plus 2, the derivative is x squared. 1/3 x cubed plus 100, the derivative is x squared. 1/3 x cubed minus 7, the derivative is x squared. So what we do is we call that 1/3 x cubed plus c, and we call that c the constant of integration. And then that 1/3 x cubed plus c represents the whole family of antiderivatives. The notation is this funky looking S curvy line thing here. That's called your integral sign. And you will often see it written with the integral sign and then f prime of x dx, and then that would of course be equal to f of x plus c, because if you find the integral of the derivative, then you're going to end up back with the original function. So integration, antidifferentiation, is basically the opposite, or the going backwards, of differentiation. If you had the integral of a function already called f of x, then when you find the integral of that, you would give it a capital f of x. And of course, we're adding on the constant of integration. Notice also that when you have your integral sign, this funky looking s thing is always followed with this dx, which is very important, and it tells you with respect to which variable you're finding the integral of. If sometimes it's t or h, and so that would be followed with dt or dh. And then we would read this as the integral of f of x with respect to x. So the formulas that you're going to have in the formula booklet are here, and you'll see them in the formula booklet. All right, let's do an example. So here we have the integral of 1/x cubed minus the square root of x. The first thing I'm going to do here, I'm going to rewrite the integral function to make it a bit easier. So I'm going to make that 1/x cubed as x to the negative third, and I'm going to make that square root of x as x to the 1/2. Notice I still have the integral sign and I still have the dx. I haven't actually integrated yet. I'm just rewriting the original problem. Then the integral of x cubed, x to the negative third, is the rule is that you're going to add 1 to that exponent and divide by that new exponent. So negative 3 plus 1 is -2, and then divide by that new exponent of -2. Same rule here. You're going to add 1 to the exponent of 1/2. You're going to get 3/2, and then you'll divide by that new exponent 3/2, and then you're going to add on the constant of integration. And then the last step is to clean this up a little bit. So I'm going to put that x to the -2 down to the denominator. I'm going to put that negative out to the front, so it'll look like this. Negative 1/2 x squared, so that x to the -2 went down to the bottom with that 2 that was already there. And over here, dividing by 3/2 is the same as multiplying by 2/3. And then I changed the x to the 3/2 to be the square root of x cubed, and I added on my constant of integration. And we're done with this problem. Okay, example 3, I know the numbers are off, and there's a reason for that, but I'm not going to tell you. We have the integral of 2 sine x minus cosine x with respect to x. Now, this first step here, I'm using a property that's called the difference of the integrals is the integral of the difference is the difference of the integrals. So I'm just doing each of these separately. So I have their own integration sign and dx with the sign, and I have an integration sign and a dx with the cosine. So I'm going to do these separately, and then I can put them together. The other property is that if you have the integral of a constant times a function, you can pull that constant out in front, much like I have here, my 2 out in the front, and then multiply that by the integral of the function. So the integral of sine is negative cosine, and the 2 carried down, and then the integral of cosine is sine and the negative carried down. And add on the constant of integration, and we're done with this problem. All right, this is another problem where we're going to do integration, but we're also given a condition, and we're going to be able to figure out what is the value of that constant of variation. So what we want to do is find f of x given the derivative. So we want to integrate the derivative, and we'll find f of x. So that's what, oh, wrong button, sorry. So I want to do the integral of the derivative, and that's going to equal the original function. So what I have here is I put the integral sign here in front of the derivative function, and I put the dx on the end. So the integral of sine 2x minus the square root of x with respect to x, and that's going to equal f of x. Now this next step is similar to what I did in the previous example, where I'm separating the integrals. They each get their own integral sign, they each get their own dx, and then I also pulled out that constant of 2 out in front. The integral of sine x, we said earlier, was negative cosine x, so that becomes negative 2 cosine x. And then we also did this one earlier. The integral of x, the square root of x, would be x to the 3 halves divided by 3 halves, because that's really x to the 1 half, so you have to add 1 to the exponent, divide by the new exponent, and add on the constant of integration. Now that's all equal to f of x. In this next step, I'm just going to clean it up a little bit. So again, dividing by 3 halves, that means multiplying by 2/3. So that equals f of x, but they also told us that f of 0 is equal to 4. So f of 0 is equal to 4. That means I'm going to substitute 0 for x into this function and set it equal to 4, and I'll be able to solve for c. So here I'm showing you substituting the 0 for the x, so that's negative 2 cosine of 0 minus 2/3 times 0 to the 3 halves plus c is equal to 4. Cosine of 0 is 1, and then negative 2/3 times 0, well, that's just going to be 0, plus c is equal to 4. And so I really just have negative 2 plus c equals 4, so c equals 6. Now that I have the value of c, I can take that c, plug it back into this integral function here, and I will have the full f of x as negative 2 cosine x minus 2/3 x to the 3 halves plus 6. And we're done with that example. All right, this is a bit more with integration, but this time we're going to be doing it with a composition of a linear function. So let's just consider the function y equals 3x minus 4 to the power of 5. If I were to find the derivative of that, I would have to use the chain rule. So that would be 5 times 3x minus 4 to the 4th times 3. So that would be, remember, with the differentiation, we're going to bring that exponent down to the front and subtract 1 from that exponent times the derivative of the inside. And if I clean that up, I'll get 15, 3x minus 4 to the 4th. Now the challenge is, what if I wanted to go backwards? I'm given 15 times 3x minus 4 to the 4th, and I want to go backwards. I want to integrate to end up with a 3x minus 4 to the 5th. Well, if I use the rule that I just learned a second ago about add 1 to the exponent divided by the new exponent, then that's going to be the 15 is just going to come down. We're going to take the 3x minus 4. We're going to add 1 to that exponent. That becomes a 5, and divide by that new exponent. And if I stopped here, I would be close to the original, but I wouldn't actually have the original, because that 15 over 5, that gives me a 3 out in front. But there was no 3 out in front here. So what I'm going to do is I'm going to get rid of that 3 by multiplying by 1/3. Okay? Then you can see if you simplified here, I would end up with 3x minus 4 to the power of 5. And the reason we multiplied by 1/3 is because you see how this is like a linear expression inside of here, 3x minus 4? This is, if you think about this in terms of like mx plus b, your slope would be 3. So that's the rule there, is you're always going to multiply by 1 over your slope. Okay, let's look at another type of example. If I had y equals e to the 7x minus 1, the derivative would be e to the 7x minus 1 times 7, which would be the derivative of the inside. If I were going backwards, I would want to, the integral of e to the 7x minus 1, of course, is e to the 7x minus 1. And I'm dividing by that 7 because the 7 is the slope on that linear expression. It has nothing to do with the 7 in the front. It has to do with the 7 being the slope. And then, of course, the 7s would cancel, and you would end up with your original e to the 7x minus 1. Let's take a look at an example here. We're going to integrate this function. The first thing I did is I just pulled the 3 out in front, so I didn't really do anything other than pull the 3, which is a constant, out to the front of the integral sign. Now I'm going to use that power rule. I'm going to add 1 to that power, divide by that new power. But this is not the only thing I have to do, because this is a linear expression inside here. So I'm going to now multiply by 1 over the slope, which would be -2. Add your constant of integration. Then in the next step, you want to clean that up. 3 on the top, and then that's going to be -12 on the bottom, so it makes it a 4. And then I put the negative on the top there, plus the constant of integration. And we're done with this problem. I'm going to stop the video and make a second one.